All right, guys, continuing on with our Unit 1 um, focus on equations and inequalities. Today we're going to be talking about proportions. So up at the top, you'll see we're going to be talking about ratios and proportions. If you are taking notes on a scrap sheet of paper, just make sure you're labeling those and putting your name on it for when you turn in. And if you printed them out, awesome. You can just follow right along. So let's go ahead and get started with some vocabulary words. Two common words that you're going to see today, ratio and proportion. Now, you've seen these things before, but just a reminder, all a ratio is a comparison of two numbers. You can write ratios in all different forms. The most common ways you'll see them are with a colon between. So if we're comparing like 1 to 2, we could write it like that. We could write it as 1 to 2, or the way that we'll be writing it most common today is as a fraction, 1 to 2. On the other hand, a proportion is when you set two ratios equal. An example of this would be like 3 to 6 is the same thing as 4 to 8. Now we're going to talk about these two vocabulary words in context and word problems today. But before we do that, since we are solving proportion word problems, we need to review how to actually solve a proportion. So when you set two ratios equal to each other, you can solve for this unknown by cross multiplying. When you cross multiply, you'll multiply either diagonal first, it doesn't matter. But if we multiply 3 times x, we would of course get 3x equals 9 times 5. So we have 3x equals 45. Then you've just got a one-step equation to solve there. Go ahead and divide by 3, and we get ourselves x equals 15. Now, just like with any other equation you're solving, you could plug that in to make sure it balances out. Let's say we did plug it in. 3 over 9 equals 5 over 15. Both of these fractions, of course, reduce to 1/3, or you could solve it by cross multiplying. 5 times 9 is 45. 3 times 15 is 45. So we've balanced that equation out. If you look to the problem to the right, you'll notice that we have variables in both denominators, and we've got full expressions in the denominators. It's going to work in the same pattern. Just make sure that you're using the distributive property. So this 4 is multiplying with all of the x plus 2. We're going to set that equal to 2 times all of x plus 6. Notice that I'm putting those in parentheses. I would do the same thing on your notes to remind yourself that this 4 is multiplying with both the x and the 2, as well as the 2 multiplying with both the x and the 6. Go ahead and multiply that out. And continue solving. I'm going to have to zoom out a little bit. I ran out of room. Just like with the problem before, you can always take that value of 2 and plug it back into the equation if you wanted to check your work. So if you're taking an assessment or something and you wanted to check, always do that. You should be able to turn that problem in and know that you've gotten it all correct. So those are just kind of boring problems out of context. When we're dealing with word problems in proportions, you're going to want to remember a couple things. First of all, when you're creating the proportion, you want to make sure you're creating a proportion where the units line up in your ratios. So what I mean by that is you're going to usually be comparing two things. You're going to want unit 1 in the first ratio to go with unit 1 in the numerator in the second ratio. Whatever unit 2 is, if you choose it to be in the denominator, It needs to be in the denominator in the second ratio. Then, just like before, you will cross multiply. So let's look at a basic example down here. This problem tells us that Emma sketches 7 pictures in 3 days. At this rate, how many pictures will she sketch in a whole semester of 95 days? Now, your first job is to figure out what two things are we comparing. Well, we're comparing pictures with days. I'm going to go off to the side, and I would encourage you to do this too. Remind yourself you're comparing pictures with days. So that when you set up your proportion over here in these boxes, you are putting the correct unit in each box. So we know that she can do 7 pictures in 3 days. This 95 days we're going to put in the denominator with the other units of days, and we don't know how many pictures she's going to create in those 95 days. We'll then cross multiply just like we did before. So we get 3x equals 3 times 95. Now, I would make sure that you're pausing and making sure you can do this on your own. I would make sure you have your calculator close by. Oops. 7 times 95. My bad. So we have 3x equals 665. Divide by 3, and you get x is 221. Now, one thing I'm very picky about is labeling that answer. I want you to think about 221 what? Well, if you forget, just go back to your proportion over here. X was in our numerator. That went along with pictures. You can also look at what the question was asking. How many pictures? 221 pictures. Label your answer. Box it. Take a second and read this next problem on your own and try to figure out the two things we're comparing, and then try to write those 2 units off to the side. Pause the video if you need to. All right, hopefully you were able to read through this problem and figure out the 2 things that we're comparing here. So we have John eating 15 grapes in 1 minute and 20 seconds. If this rate continues at this rate, how many seconds will it take for him to eat 85 grapes? Now, one of those units that's nice and clear. Oops. Grapes. He's eating grapes in a matter of what unit? Well, we see back here 1 minute and 20 seconds, and we want to answer the problem in seconds. So we're comparing grapes to seconds. Now we need to set up our proportion. Now, when you look back at 1 minute and 20 seconds, hopefully you're able to remember that 1 minute is 60 seconds plus 20. So we get ourselves 80 seconds back here. So we can eat 15 grapes in 80 seconds. That's actually kind of fast. We don't know how many seconds, so make sure that you're putting the variable with the seconds in our denominator. If you flipped it all around, that's fine as long as you're keeping it consistent. He's going to eat 85 grapes. Go ahead and do your cross multiplying. Wha-bam, wha-bam. And keep on solving. So we have 15x equals 80 times 85. Keep that calculator handy and do that on your own. Don't rely on me to do all your math. 6,800. Divide by 15, and you get x equals 453. Hopefully you're looking at that and thinking, oof, that is not a correct answer. Why not? Why is it not complete? Because it doesn't have a label. Make sure that you're getting that label on your final answer and then boxing it. So it's going to take them 453 seconds to eat 85 grapes. We don't need to change it back to minutes because the problem asked us simply for seconds. Let's flip it over and try out this back page. On this back page, we're going to continue to look at ratios and proportions. We're going to start out here talking about Tucker and his comparison with Tanner collecting Pokemon. So we know this problem tells us that Tucker is catching 2 Pokemon in 6 minutes. Tanner is catching 5 Pokemon in 15 minutes. Right ratios representing Tucker and Tanner's rate of catching Pokemon, and we want to figure out, are they catching Pokemon at an equivalent rate, or is one person catching them faster than the other? So we've got Tucker and we've got Tanner. So Tucker is catching 2 Pokemon every 6 minutes. Tanner is catching 5 Pokemon every 15 minutes. Now we can see that our units are the same comparison, but we want to see if one ratio is larger than the other. Let's take a look at these and reduce these fractions. 2 over 6 reduces to 1 Pokemon every 3 minutes. 5 Pokemon in 15 minutes reduces to 1 Pokemon every 3 minutes. So we can say that Tanner and Tucker are catching them at equivalent rates. Those ratios are exactly equal to each other. 1/3 is equal to 1/3. Their friend Ethan, on the other hand, what can we find out about him? He catches 7 Pokemon in 14 minutes. Does he catch his Pokemon faster or slower than Tucker and Tanner? And how do we know? So let's check out his. Ethan catches 7 Pokemon in 14 minutes. If we reduce that fraction, we would know that he catches 1 Pokemon every 2 minutes. So it's taking Tucker and Tanner 3 minutes to catch 1, where it's taking Ethan 2 minutes to catch 1. So I want y'all to think about if Ethan is catching them faster or slower than Tucker and Tanner. Compare those ratios. Hopefully you were able to figure out that Ethan is catching them faster. It takes less time, in other words, for him to collect 1 Pokemon as compared to Tanner and Tucker. If Ethan continues to catch Pokemon at this rate, how many Pokemon would he catch in 53 minutes? Can you create a proportion for this situation to help you solve it? And then write a proportion and solve. So I'm going to give you all a second, pause the video, try to set up your proportion to solve to find how many Pokemon he can catch in 53 minutes. Just like before, we're comparing Pokemon with minutes. From the problem before, we knew that it took him 14 minutes to collect 7 Pokemon. Now we're throwing in 53 minutes. Make sure that you keep that minutes in the same location that you kept it in the first ratio. We don't know how many Pokemon he's going to collect. Go ahead and do your cross multiplying. We get 14x equals 53 times 7. 14x equals 371. So x gives us 26.5. He cannot collect half a Pokemon, so we'll say that he collects 26 Pokemon. Make sure to put a label on that final answer. Pause the video, rewind if you need to check out any part of that problem, comparing ratios and setting up proportions and solving before we move on to these last 2 problems. Alrighty, let's check out these last 2 problems that deal with some proportion word problems. So we've got American Eagle's workforce consisting of store employees, store managers, and corporate managers in the ratio 10 to 3 to 1. Now that order is going to matter. Store employees to store managers to corporate managers goes in the order of 10 to 3 to 1. How many employees are store managers if the company has a total of 1,260 employees? So from our question over there, we know that we're comparing store managers to the total number of employees. Now, we know from our little ratio that they gave us that the number that corresponds with store managers is the 3. How could we find the total from this ratio? Hopefully you're thinking, oh, well, we could just add them all together. 10 plus 3 plus 1 gives us 14 total in that specific ratio. So we know that there are 3 store managers if you have a total of 14 employees. In this question, they're asking us how many store managers there will be if there is a total of 1,260 employees. So plug that 1,260 in to the appropriate location. We don't know how many store managers there will be, so we put an X in that location. Just like with the problems before, we'll cross multiply to solve and continue solving that problem. Make sure before you put your final answer on there that you've labeled it. It's always a good idea to make sure that your answer makes sense. 270 store managers, if there's a total of 1,260 employees, anything over 1,260 as an answer would not have made sense. So make sure that you're double checking your answer makes sense. Pause the screen, read that last one, and go ahead and try it on your own. In this last problem, members of VHS Student Council are selling t-shirts for rivalry games, which hopefully we get to do that this year because it's very fun. The ratio of smalls to mediums to larges sold occurs in the ratio of 8 to 5 to 7. So we know that 8 goes with the small, medium is 5, large is 7. If 300 total shirts are sold, how many are mediums? From that question, we know we're comparing mediums to the total. In our first ratio, back here, we know that 5 mediums are sold when compared to a total of, well, just like the problem before, what should we do with that 8 and the 5 to 7 to find the total? Add them. 8 plus 5 plus 7 gives us 20 total t-shirts. So for every 20 t-shirts sold, 5 are mediums. Now we have 300 actual t-shirts sold. We want to find out how many are mediums. That's what your proportion should look like. If the numbers are all flipped, that is A-OK. Cross multiply, continue solving that problem. Should have gotten 75 mediums. So if you did that problem on your own, just want to fast forward, make sure that you get 75 medium t-shirts. The homework will go over similar problems, so make sure that you're reviewing over these notes if you need to. Remember, your notes should look similar to mine. Work out those problems, set up those proportions, label those answers so that you can be successful on that first assessment and beyond.